Alright folks, you're welcome to yet another exciting session of co-prime statistics. My name is Isaac Kofi J and I welcome you to the session for regression analysis. As I always say, if you've not subscribed to our channel, kindly do all to subscribe. And if you are new here after subscribing, kindly make sure you press on the bell icon so that you don't miss any updates from co-prime statistics. In this lecture, we are going to find the expected value of beta cap under a multiple linear regression model, or we want to show that the expected value of beta cap is equal to beta in a multiple linear regression model. So in the previous lecture, we said that a multiple linear regression model, y, which is our dependent variable, is equal to x beta plus the error term. Okay, so now let's denote this as equation 1. And then we also made mention that your y and your error term are random variables. Okay, but your x and your beta are not random. Kindly take note of this. Okay, and also note that in a multiple linear regression model, your y, your x, your beta, and your error term are all matrices. Okay, so everything that we are doing here, we are doing it in a matrix system. Okay, so kindly take note of that also. And also take note that your error term, which is u, follows a normal distribution with expected value or mean 0. And very important, we are going to use this in the subsequent slide. Okay, so take note of that too. Now let's proceed. Okay, so now in the previous lecture as well, we were able to prove that the estimated value of beta, which is beta cap, is equal to x prime x inverse times x prime y. Okay, so amongst these two variables here, our x is not random but our y is random. Okay, so now let's find the expected value of beta cap. So expected value of beta cap is now equal to the expected value of this whole matrix. So we have x prime x inverse times x prime y. Okay, now because our x is constant, you have to note that the expected value of a constant, let's say a, is the same as that constant a. So if you are considering this whole matrix as a constant or a matrix which is not random, and if this x prime is also not random, that means if you find the expected value, you are supposed to get the same matrix. Okay, so this means that the expected value of beta cap will now be equal to x prime x inverse times x prime and the expected value of y, because y is random. Okay, so now our interest is to find the expected value of y as well. Okay, so in equation 1, we said that y is equal to x beta plus the error term. Okay, so it means that if you want to find the expected value of y, you have expected value of y which is equal to expected value of x beta plus the error term. Okay, expected value is the same as the mean or average. Okay, and we've stated that the error term u follows a normal distribution with expected value 0 and variance sigma squared. It means that the expected value of the error term is equal to 0. Okay, so this implies that the expected value of y expected value of y is now equal to x beta, because x beta is constant. So if you find the expected value, is the same thing plus the error term 0. Okay, it means that the expected value of y is equal to x beta. So wherever we see expected value of y, we are going to substitute x beta. Okay, so this means that now the expected value of beta cap is now equal to x prime x inverse x prime times x beta. This is the expected value of y. Okay, so now kindly take note of this as well. X prime x inverse is one matrix, x prime x is also one matrix, and beta is also one matrix. Okay, so this means that we're actually going to apply some rules in matrices here. Okay, note that in matrices, if you multiply any matrix, say matrix A, by its inverse, you're supposed to get that you're supposed to get the identity matrix. Okay, so if you multiply any matrix by its inverse, you're supposed to get the identity matrix. Okay, and if you multiply any matrix, say A, by its identity matrix or the identity element, you're supposed to get that same matrix. So kindly take note of these two properties. We are going to use them here. Okay, so we have the expected value of beta cap is now equal to x prime x inverse and x prime x beta. Okay, so if you realize, we are multiplying x prime x by its inverse, and the rule is saying that if you multiply any matrix by its inverse, you're supposed to get the identity element or the identity matrix. Okay, so it means that the expected value of beta cap is now equal to the identity element times beta. Okay, and then we also stated that the identity element times any matrix is the same matrix. Okay, so it means that the expected value of beta cap is equal to beta. Simple as that. Okay, so finally we can state that the expected value of beta cap under a multiple linear regression model is equal to beta. This means that beta cap is an unbiased estimator of beta. Okay, so simply put, the expected value, we've been able to prove that the expected value of beta cap is equal to beta under a multiple linear regression model. I hope this lecture was helpful. Kindly check our playlist to get more of such videos under regression model. And kindly do also press on the bell icon so that you don't miss any updates from Co-Prime Statistics. Thank you very much for watching.